Hello everyone. In this session, with the help of demonstration, we will see step-by-step Git workflow. We will also see how branching is done in Git, and then at the last, I will give you some best practices for using Git. Now let us move to our editor, VS Code. To be able to use Git into our local system, we should install Git through its official website. This is the official website of Git, which is called as https://gitscm.com, which can help you to download Git software into a system. You can select for Windows. Since I'm using a Windows machine, I will be downloading a setup for Windows. You can just select the Windows x64 setup and it should be fine. Once the file is downloaded in your system, you can follow the simple install setups and it will be starting to work in your system. Once the Git is downloaded in your system, you can now open VS Code and run Git wherever you want. When the Git is installed, it also provides you a terminal of its own, what is called as Git Bash. Now that we have Git installed into our system, what we can do is create a folder which will act as an empty repository for the Git. To be able to do that, what I'm going to do is I'll go to terminal and click on new terminal. By default, it is going to open a command prompt, but I want to open a bash terminal. To be able to open bash terminal, you can just click on drop down here. And then since the Git is installed, you can see a Git bash terminal here. Now this is how a Git bash terminal looks like. Since this is open in the same folder we are working, it has already been redirected to this directory. As you can see demos, which is this. Now what I'm going to do is create an empty directory which will act as empty repository. To be able to create an empty directory, I will write mkdir, then name of the directory that I want. So I can write git-demo. Once this is done, you can see that an empty repository or empty directory for now is created. To make this work as an empty repository, what I need to do is navigate into this directory. cd git, and if I simply put tab, it will give me the directory. Now you can see that I've been redirected to the git demo folder. Whatever I work here will happen inside the git demo folder. Now what I want to do is create this as an empty repository. To be able to create this as an empty repository, I will write git init. So this will initialize Git inside this repository, inside this directory, and create an empty repository. Once the initialization is done, you can see that this now starts to show the master branch. So the default branch that gets created when you create an empty repository is the master. What also happens is an invisible .git folder gets created inside your repository or inside your directory. Now, this folder is being tracked by Git. The files and folders that I make within it, the code changes that I do within it will all be tracked by the Git if I want to. So I'll start off with creating a single file within it. Let's say we create readme.md. All right. So once a readme.md file is created, you can now notice that there is a U symbol here, which stands for untracked. What this means is now Git is initiated into this directory and it will look for any new files. If a new file is created, it will mark it as an untracked. This can also be seen by the command called git status. So when you write git status and hit enter, it will tell you that you are currently on the master branch. There are no commits done into this branch. At this point, the files that are untracked are readme.md and there is nothing to commit. Whenever there is something to commit, it will go into the staged area. So the next step that I need to do is add this file into a staged area. To be able to add this file into the staged area, what I'm going to do is write git add followed by the file name readme.md. Once it gets added to the stage area, you can now notice that the U symbol has now been replaced by A symbol, which stands for added or which stands for staged area. Once the file is added into the staged area, we can make the commit. Now, before we commit, we will just add some content into this README file. In our case, I will just write, this is a demonstration. This is the demo file for the demonstration purpose. I will just save it. Now, if you notice, the moment I save this, the A symbol now gets converted into M symbol, which stands for modified. That is, the file which was being tracked by the Git is now modified. and Git will tell you that it is modified. To also check that whether it is modified or not, you can also do that with the help of this command, git status. So when you write git status, it will give you every other information, but it also tells you that, okay, there is a readme.md file which is newly created, which is added, but now it has been modified. To be able to convert this modified file into a staging area, we can write git add. Now in the last part, I said you can write you can write the file name here. But at the same time, when there are multiple files to be added together, what you can also do is write -a, hyphen capital A. What this does is it will take all the files that are either modified or are untracked into staging area. Now you can see that it has now been added to staging area, and then the M that was originally there, now it got replaced by A. Once the staging area is done, once the content is added to the file and it is added to the staging area, now we can make the commit. Please note, the files that are added to stage area will only be committed. That is, only the staging area files are committed. If you create a file and it is untracked, if a modified file is there into the application, it will not be committed. Only the files in the staging area will be committed. Now, if I make a commit, I will write git commit. Now, every git commit requires a commit message. This commit message should be a representation of what change happened with that commit. In this case, we have just added a README file. So I'll write initial commit. Okay. And then finally, I will write updated or added readme.md file. Okay. And then you hit enter. The moment you hit enter, the commit has been made. Now, what exactly happens inside the Git is the Git takes a snapshot of the current stage of the application. Whatever is the file structure, whatever folders we have created, whatever files we have created, whatever databases are there, everything will be taken care of at this point. Everything, the snapshot of every part of that will be taken with this commit. This is the beauty of Git, because if let's say if I want to come back to this place, I can always come to this commit. All right, so the next step of this is to push this code to the remote repository. Now, before we push this code to the remote repository, we should have a remote repository for that. To be able to create a remote repository, we will move to the GitHub user interface. Now, this is my GitHub user interfaces. So if I, let's say, go to the home page, you will see certain links, certain suggestions, and certain things about the Git. What I want to do is create a new repository. So in order to do that, what I will do is I will click on this plus icon here, which will give me options to create certain new things. So it can be anything. It can be issue, it can be a repository, it can be a new code space, new gist. In our case, we are going to just create a repository. So I'll go to the new repository and click enter. Now, once you click on that, it will take some general information about the repository, which is the repository name, which is going to be very important in our case. This is going to be Git demo, all right? Because since we are working on the Git for the very first time, let us name it as Git demo, followed by a description. So this description is an optional thing, but it is always recommended to give a description so that you know what exactly this repository is all about. All right, so I've given a demo or optional description. This is a demo report to understand working of Git. In general, or by default, the repository is created by public, but you can decide whether you want to make it public or make it as a private repository. In our case, we are going to keep it public. Generally, it is recommended to click here and add a README file when you create a repository. But since we are going to connect it with our local repository, which already has a README file, we will not keep it checked. So we'll keep it unchecked and then leave it as it is. Rest of the things can be left as it is. And finally, we'll click on create repository. All right. So when a new repository is created, it has nothing, right? So the only file which could have been there, that is a README file, that also we did not create. So at this point, this repository does not have anything. What it has is this, right? So this is the URL of the URL of the repository. So I can just copy this because I want to set this as a remote. Now, what do I mean by remote? I will tell you in the VS Code. Now let us go back to our local repository. Okay, I will clear the space. All right. Now here we need to connect the local repository with the remote repository created. All right. So what we are going to do is we will add an origin. So this origin would refer to the URL of the remote repository that we are going to connect it with. So let me first write remote, git remote hyphen v. So currently it does not say anything. This means that there is no remote set. That is, the Git locally does not know which URL to go to or which URL to connect with. To be able to do that, what we are going to do is write git remote add origin and then followed by the URL that we just copied from our GitHub UI. When I do that, this is now going to add this as an origin. So next time when I want to refer to this URL, I can simply say origin. So let's say when I write git remote hyphen v, it will tell me that, okay, this is an origin. And what is the URL placed inside the origin? This is the URL placed inside the origin. So let's say now whenever I push my code to the remote repository, it is going to by default go into this repository unless I make the change. Now that the origin is set, let us try to push this to the main repository. Now, if you note, the branch created here by default when you initialize this as an empty repository is the master branch. So master branch is created locally. Whereas in GitHub, by default, the branch that gets created is the main branch. So to be able to, push the code locally from local to the remote, what we are going to do is create a main branch. So the branch on either side remains same. To create a branch, I will write git branch main. Now what it has done is created a main branch. To be able to go to or to be able to switch to main branch, we can write git checkout main. All right. So what it does is it has shifted your entire code to the main branch. Please note, whenever you create a branch, exactly same copy of whatever we have in the current branch gets created with the new branch. So if I had this readme.md in the master branch, when I create a main branch at this stage, at this particular instant, the complete code gets copied to the main branch also. So both of the branch now are at the same level of with respect to the code. Now, what this gives me is I can directly copy the content from my main branch, which is locally, to the main branch that is there in the remote. Okay. To do that, what I'm going to do is I'll write git push origin main. Now, what do you mean by this command is I'm trying to push to origin, which is this endpoint or which is this URL, and what exactly or which exactly is the branch that I'm going to select? Main branch. So the main branch here is going to go to the main branch there. All right. So when I hit enter, what happens is the entire code has now gone from locally to a remote repository. To be able to check that, what I'm going to do is go to the GitHub and simply refresh and now see that the entire code which I have locally is also now put under the Git. You can also see that there is one commit which is exactly the same commit we have done locally, and whichever file are changed with that commit, the commit message will be shown here. So for example, in our case, we have changed the readme.md locally and then push. This means the initial commit will now show along with the readme file. Okay, so that is how we push the code from locally to repository. Now at this point, what I have is I have a local repository. I can make a change to it, and whenever I want to push this code to the remote repository, I can just use git push. I just need to make a commit before that. Now let's say there are multiple people collaborating on this repository. So let's say if I have another fellow developer that is working on the same repository, there is always a chance that he or she can make changes and push the code to the remote repository. So there is always a possibility that the code you have locally might be different from the code that you have at the remote repository, right? So in that case, it is always important to make sure that you have same code or same level of code locally as well as remotely, right? So I'll just try to show that in the form of demonstration. I'll go to the GitHub UI. What I'm going to do is create a new file. So let's say if I want to create a new file, I'll just write add file and then create new file. Here, I can name the file as, let's say, index.html. index.html, and here as a content of it, I will just simply write h1 tag. Now I'm not going to follow the entire syntax of HTML. I'll just add a dummy content here. This is a dummy HTML content. All right, and that's all. For the demonstration purpose, this is fine. Now, what I'm going to do is, if you want to save a file, if you want to commit a file remotely, you just have to make a commit. Right. So when I create a commit, when I click on the commit changes, what it does is it creates a commit message which is relevant to what I've done here. If you want to change this, you can change this. If you want an extended description, you can also add this. In this case, I think this is fine. So I'll just click on commit. All right. So now we have two commits. So let's say if I go to the main file, if I go to the home page of this repository, I see that there are two commits. Whereas in my local repository, there is only one commit. Right? So the current status of the code here in the remote repository is completely different than what I have in the local repository. Right? So in this case, there is always a chance of conflict, right? So conflict means that there is the code base that is there in the local repository is different from what you have in the remote repository. And this is going to be the case when you are working in a collaborative manner. So what you're going to do is, before you make a change to the repository, it is always advisable to pull the changes from the remote repositories first and then make the changes. So this will resolve all the commits. So what I'm going to do is, let me show you with the help of VS Code. All right. So this is my local repository, and I know that there is a change in the local repository and the remote repository. So what I'm going to do first is make sure that the status that is there in the remote repository is locally pulled, and only then I start making changes. To make sure that I make the current status of my local repository exactly same as the current status of remote repository, what I'm going to do is do a git pull. So what I'm going to do is write git pull. Now, where I'm going to pull from, I'm going to pull from origin. And which exactly is the branch? It is the main branch. All right. So when I do a git pull, you can see that there is this index.html which is pulled. This index.html would refer to the added changes that we have. This kind of can be shown here also, right? So you see that +1, there is one file change and one file insertion. What is that insertion? It is the index.html. So this status is shown with respect to the current status of the repository, right? So what has happened in my local repository, which only had a readme.md file, now I also have an index.html file. And at this point, the code base that is there in the remote repository is exactly same as the code base of the local repository. So what I'm going to do now is make a change and push it to the original repository. So what I'll do is now I'll create a new file here within my git demo, which is going to be, let's say, home.html, home.html. In the home.html, I will create a complete HTML file. Okay, so this can be, let's say, h1. This is my home file. All right, this is my home file and make a save. Now you can see again, the same process is getting followed. When I create a new file, let's say home.html, it will tell you that it is untracked. So the Git does not know or is not tracking the current status or changes in the home.html. To make sure that the Git tracks this, what I'll do is I'll write git add -a. I don't need to worry about what file is created, what file needs to add. Simply -a will take care of it. And then finally, I'll make a commit. Git commit followed by a intuitive message. So in this case, the message is going to be added home.html file, right? So once the commit is done, it will tell you some changes here. What are the insertions? What are the deletions? How many files have been changed and so on, right? Once the commit is done, I can simply push it to the origin. So it would be git push origin main, right? Very similar to a pull command. Okay, now this code has now been pushed. So if I go back to the original UI of my GitHub, the remote repository and refresh it, you will see that the home HTML is there, and you can now you can see the difference what I was suggesting, right? So initially the README file was changed with this commit. So initial commit added README file. Index.html was done with this commit, create index.html, and finally the home.html was done with this commit. So whichever commit, whichever file changed with that commit will come here. So for example, now if I make another change in home.html and then make a commit, updated home.html, so this added home.html message will now be replaced by updated home.html. So this is how I will know remotely as well as locally what changes has been done, what files have been changed, what is the commit, how many commits are there. And if I just click on commit, I will also see the different stages of the commit, right? So if I click on any of the commit, I can go to that state of the repository. Next thing that we're going to see is how branching is done with Git. Yes, we have created a main branch and we have shifted to the main branch, but I will now give a brief understanding, a detailed understanding, in fact, of what branching is and how do you work with branches. All right. So let's say I'm in this main branch and I want to test a new feature, right? So for example, I want to see how a form can be added into this home.html. All right. But at the same time, I don't want that the main flow of the application, the main branch or the main repository gets affected with this. Since the feature that I'm trying to do is just a testing feature, I'm not sure whether it is going to work or not. So what I'm going to do is I will create a branch and make a change there. All right. So how do I create a branch? I'll write git branch, and then finally I will name it anything. In this case, I will just name it as feature form. All right, because I'm going to create a feature which is related to a form in HTML. So I'll just write this and then hit enter. Okay, what it has done is created a branch with the name feature form. All right, if I want to see how many branches are there with associated with this repository, I can simply write git branch. All right, so you can now see that there are three branches: feature form, main, and master. The one marked in green will tell you what is the current branch we are on. Right, so currently we are on main branch, and this is the new branch that has been created. If I want to shift to this feature form branch, what I will do is I write checkout, git checkout, and then followed by the branch name, feature form. Okay, so now it says switch to branch feature form, and now we are in the feature form. So as I said, whenever you create a branch, the branch will be created with the exact same code at that instance when the branch was created, right? So at this point, when I created the branch, I had this home.html, index.html, readme file, and the same code is followed here. All right. Now let's say if I make a change in this file here, let's say if I remove the h1, okay, and now I replace this h1 with a proper form. So let's say if I write a form here. Okay, it says actions, which I will just simply put it here. Then I'll create an input tag, type text. All right, and then I will simply just write, or I'll create a label here. All right, label for, let's say, my hyphen form info. And here finally we are going to write ID, which will be same as my form. All right, and this is followed by a submit input, right? So input type, we will change it to submit. Okay, submit, and I think that's all. All right, so this is a form that I want to create in the home.html, which is just an experimentation. I'm not sure how it will affect the main application, and that is the reason I don't want to affect or don't want to change the code that is working in the main application. All right, so once I make a change on this, it will now tell me that okay, you have tried to modify home.html, right? So it will tell you that it is modified. How can I check it? I can also check it with the git status uh, code, right? So when I write a git status command, what it says is on the branch feature form, right? So currently you're on branch feature form, and there is a file called modified. There is a file home.html which is modified. All right. At this point, there are no changes to commit. Okay. So what I'm going to do is to be able to commit, I need to add this modified home.html into a staging area, right? How do I do that? Very simple. Git add hyphen a. I don't have to worry about what is the file that I'm adding, what folders are being added and all. Hyphen A will take care of it, right? Now my home.html is added to staging area. How can I check that? I can check that with git status. At any point, if I want to check what is the current status of the file, whether it is in the whether it is untracked, whether it is in the staging area, whether it is modified, even if the VS Code does not show this, you can always go to git status and see this. So now you can see that the home.html has been modified. All right, and this is being tracked now. Okay, it is tracked and being modified. Now let's say when I do a git commit, I'll write git commit -m, I write modified home.html with form. All right. Now I've made this commit, but this commit is with respective to the branch feature form. All right. This commit has not happened to the original flow or the main branch of the application. So this is again another feature that Git provides. The changes that you want to do and try out will only be happening in the current feature branch that you have created. You can keep this a different branch as long as you're not sure that it needs to be merged to the main branch, right? So if you see that the feature form is having this modified home.html, if I move back to the main branch, let's see what happens. So how do I move back to the main branch? I will write git checkout main, right? So the moment I move to the main branch, you can see that the form is gone. Okay, so basically it has not gone anywhere. It is only that the main branch, the home.html version that is there in the main branch does not have that form. All right, so it has not disturbed the original or the main branch of my application. It has only made change in the feature branch. Unless and until I'm not sure, I will not merge that feature into the main branch. Hence, I will avoid any loss of data, I will avoid any breaking of code anywhere, and hence work in a very, very good way by creating multiple branches if I want. All right. Now, if I feel that the changes that were made in the feature form are working, they are fine, the experimentation was correctly done, they will not break the code at any point in time. What I can do is I can merge the content from the branch to the main branch. To do that, what I will do is I will go to the branch in which I want to make the merge. So I want to merge the code from feature form into the main branch of my application. So I'll move my trigger or move my flow into the main branch. And then I will write git merge, and then what do I merge? I want to merge the feature form branch. Let's say feature hyphen form. What this will do is put the entire code in the feature form to the home.html. Sorry, to the main branch. All right, so now you can see we are still in main branch, but now we can see the form. So what has happened with this? Unless and until I'm sure that the code will not break with new addition of code, with new experimentation with the code, what I can do is I can make the changes into a parallel branch, test it out, and then once I'm sure that the code is going to work without any breaking, only then I will merge it back. Once the merging and everything is done, I will push it. All right, so how do I push the code to the remote repository? I'll write git push origin main. All right, so the entire code has been pushed. Let us go to the GitHub and check and just refresh. All right, so now when I go to home.html, you can see the commit message, you can see the form, and you can see the changed code that has come. So this is how you will play around with the branching and merging and then finally pushing code to the GitHub UI. Now that we are done with this demonstration, let us go back to our slides and see some best practices. Now that we have covered the core Git workflow and branching, let's spend a few minutes going on over some important best practices that every developer should follow when using Git. These practices might seem small on their own, but together they make a huge difference in keeping your project clean, understandable, and easy to collaborate on, especially when you're working in team. First and foremost, always remember to write meaningful commit messages. Every time you commit changes, you have a chance to describe why you made that change. Think of it like leaving a note to your future self or your teammates, explaining what this snapshot of the project is about. A good commit message should summarize the change clearly. For example, Fixed typo in README is a way more helpful than something vague like update or stuff. Commit messages are the story of your project's evolution. Clear messages make it easy to track down bugs or revisit specific changes later. Second, make it a habit to use feature branches instead of working directly on the main branch. The idea here is to isolate your work. Whenever you start working on a new feature, bug fix, or even a small improvement, create a new branch just for that task. This keeps your main branch stable and production ready while allowing you to experiment or make focused changes without fearing of breaking in anything. It also makes it easier to review and test those changes before merging them back. Another important habit is to pull before you push. If you're working with a remote repository, like on GitHub, and other people are pushing changes too, it is essential that you fetch and merge those updates before adding your own changes. Running git pull ensures you are working with the latest version of the project and helps prevent conflicts. It's a small step that can save you from major headaches, especially in a team setting. Also, be careful with large binary files, such as videos, images, or compiled assets. Git is optimized for tracking text-based files, like source code, right? When you include large binary in your repository, it slows down everything, from cloning to pulling to diffing. It bloats the repo size and makes collaboration more painful. If your project relies on large files, consider using tools like Git LFS or storing them externally. Finally, get into the habit of pushing your work regularly. Don't wait for days before pushing your changes to a remote repository. Regular pushes ensure your work is backed up and they make easier for others to see your progress, offer help, or review your code. This is especially helpful when you're working in a collaborative environment with pull requests and code reviews. So to recap, these base practice in a nutshell: write clear commit messages, use branches for individual tasks, pull before pushing, avoid tracking heavy files in Git, and push your changes regularly. These habits will not only keep your Git history clean, but also make you a more reliable and a professional developer. And your teammates will thank you for it, definitely. All right. So with that, we will close this. I hope this is completely clear. Thank you, everyone.